Today we are going to talk about graphing square root functions. You first heard about this when we were working with our family of functions unit. We are not going to be using Desmos. We're going to be graphing by hand because we want to look at domains, and we're also going to look at the shifts with H and K, which should be easier since we covered that in the family of functions unit. So to start with, we're going to look at the parent function. And so here we have the parent function for square roots. Y equals the square root of x. If we complete a data table and go ahead and complete with the values that I am putting in, and when we plug in, we found when we were doing the family of functions that you cannot take the square root of a negative, so there will be no values for y where these values of x. But the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So as we plot these coordinates, 0, 0, 1, 1, 4, 2, and 9, 3, we will complete the curve for the square root graph. And this is the starting point or the vertex. What we're going to be looking at in this unit, or this section, is we're going to be looking at the domain. So the domain are the x values for the function, and the domain will be restricted. To find the domain of a radical equation, we're going to take the expression that's under the square root, so expression under the square root. And then we're going to write that, and we're going to set it greater than or equal to 0, and then we're going to solve. And that's going to give us the lowest x value that will be possible for that function. Now, the range of any function are the y values. And so we're going to be looking at the domain and the range. So these are the steps that we're going to follow in order to graph these functions. So we're going to plot the point of the parent function that we did above. And then we're going to look at h and we're going to look at k values. And we're going to shift all the parent function coordinates based on the h and k values. So we kind of did this with a family of functions. The last thing we're going to do is identify the domain and range of the final graph. So let's look at the first example. On your notes, you can refer back to the equation or go back to the 4 steps. So we're not going to find a data table for this. We're going to find a data table for the parent function because we'll be using the same one each time. 0, 0, 1, 1, 4, 2, and 9, 3. So we'll go over here, and I'm going to use red, and I'm going to plot these coordinates. So 0, 0, 1, 1, 4, 2, and 9, 3. I'm not going to draw this in yet because we're going to be doing some shifting. So step 2 says we're going to identify h and k. So if you go back to the family of functions, h was under the radical, k was outside. So for this function, remember this is opposite, okay? So h is going to be positive 2, and since there's no number added, k is going to be 0. And so what this is going to tell me is that I'm going to shift the coordinates. I'm going to go right 2. And then I'm not going up or down because there's no k value. So I'm going to come here. I'm going to use blue. So I'm going to shift all of the coordinates, the red coordinates, 2 to the right. So this will go off. And then I will draw in the blue coordinates. I'll connect those, and this would be the graph of this function. So you're always going to plot the parent function coordinates and then shift. So now when I look at the domain, these are the x values. So if I look at the lowest x value that I have is positive 2. So x is greater than or equal to 2. When I look at the y-axis or the y values, there's no y values in the negative. So the first y value is at 0. So y is greater than or equal to 0. And that is how you graph square root functions. If you will flip to the back and we will go through these steps for some of these examples. We probably will not do all of them. So the first thing you're going to do is list the table for the parent function. So I want to make sure you note that. So let's say parent function here. So we have x and y. So it's going to be the same each time. Okay, so I'll give you a second to write that. So the first step is going to be plot the coordinates of the parent function. So I'm going to use red, 0, 0, 1, 1, 4, 2, and 9, 3. Now I'm going to go up to the equation and I'm going to find h and k. So h is going to be positive 3, k is going to be 0. And so what this tells me is I'm going to shift my parent function right 3. I'm not going to be shifting it up or down. So I will go to each of these and I will go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And this will go off the graph, which is fine. Then I will sketch the curve. The last thing I'm going to do is look at the domain and range. Domain are the x values. So if I follow the x-axis, the first x value possible is 3 or greater. So x is greater than or equal to positive 3. Then on the y, if I look at the y values, 0 is the lowest y value. So y is greater than or equal to 0. That is how you are going to, that's what you're going to do to complete these graphs. So if you move to, so try number 2 and number 3 in this column on your own when we're done, but let's go to number 4. So number 4 is a little different. And so for number 4, we're still going to start and do the same thing. We're going to have the parent function table. So the table is always going to be the same, and then we'll shift. So parent function for x and y. So it's going to be the same, 0, 0, 1, 1, 4, 2, and 9, 3. Then we will go over and plot these coordinates. So I'm going to use red again, 0, 0, 1, 1, 4, 2, and 9, 3. Second, I'm going to look at h and k. So I'm looking under the square root, and there's no number added or subtracted. So h is going to be 0, and then k is the number outside. K is going to be negative 3. So this will not shift left or right, but this tells me it will shift, the graph will shift down 3. So I take each of these coordinates, and I go down 3, down 3, down 3, down 3, and then I will sketch my curve, and this is my new graph. Now when I look at the domain and range, so I'm looking at the x values. So this coordinate is 0, negative 3. So the lowest x value I have is 0. So x is greater than or equal to 0. But when I look at the range, my y values, the lowest one is a negative 3. So it could be negative 3 or greater. So y is greater than or equal to negative 3. And that is how you graph square root functions using the parent function and then shifting h and k. Finish the rest of the examples on this page and the questions below. Check your answers. There will be a key on Schoology before you complete the homework.